Good day, class. For this video, we will talk about estimation of means. So here, we will talk about how we are going to estimate the population mean because we cannot easily find the value of the population mean because most of the population size are large. Okay, so that's why we will use estimation. Okay, first, we have the point estimate. It says that it is a specific numerical estimate of a parameter. So, to sum it up, point estimate is a single statistic value that is the best guess for the parameter value. And that is the sample mean. Again, the sample mean represents the point estimate. Okay, so we can say that the sample mean is the point estimator for the population mean. Okay, so like for example, if we have a specific value wherein that is our sample mean, therefore that value is the estimated value for the population mean. Okay, next we have the interval estimate. So this interval estimate is an interval range of values. Okay, so uh, there are options wherein we can say that the population mean is within that range of values. Okay, so we are not assuring on a specific value, but rather we will use the range of values to estimate the population mean. Let's say 1 to 5. Okay, so the population mean is approximately 1 to 5. So that is the range of values. And that is what we call the interval estimate. Okay, so here we have the illustration to differentiate the point estimate and the interval estimate. So as you can see, point estimate represents the point. Okay, so to denote that, it is a specific value or single value. Wherein, on our interval estimate, we have this segment. Okay, to denote that the population mean is approximately between that range. Okay, or between this value and this value. Okay, then we have the properties of good estimator. So when we say unbiased estimator or unbiased estimate, the population mean or the sample mean is equal to the population mean. Or the sample mean is equal to the mean of the sample means. That is what we call unbiased estimator. So, okay. Next, we have the consistent estimator. It means that as the sample size increases, the value of the estimator becomes nearer to the value of the parameter being estimated. So, kapag tumataas or dinadagdagan natin yung sample size for our estimation, our estimated value is become nearer to the value of the population mean. Okay? So, palapit po ng palapit ang value ng sample mean kapag dinadagdagan po ang number of sample size. And that is what we called the consistent estimator. Then lastly, we have the relatively efficient. So this means that among all possible statistics that can be used to estimate a parameter, the estimator must have the smallest variance. So suppose we take several samples, then we found out or we identified their variance. So alin po ang pipilian natin doon na sample? So ang pipiliin po natin na sample dapat is yung may smallest variance because most probably yung sample mean ng data na yon ay good estimator and that is closest to the parameter value or the population mean. Okay? So for the relatively efficient, the good estimator must have the smallest variance. Okay? Then let's talk about sampling error, and we have the margin of error. So when we say sampling error, that is the difference of the sample mean and the population mean. Again, sampling error is the difference between sample mean and population mean. So we can eliminate the sampling error when we use the whole population, because um, we will obtain the exact value of the population mean. In that case, there is no sampling error, right? Then when we say margin of error, that is the maximum error of estimate. So this is the maximum error that we can commit when we are estimating the population mean. Okay, maximum error. So another or additional terms, we have the Z alpha, or the critical value. So this critical value is or can be seen here, okay, at this part, because from the word itself, critical value. So this value is very important because it divides the distribution into parts called the rejection region and the non-rejection region. So as you can see, here our critical value, and the critical value divided the distribution into parts. We have the rejection, non-rejection, and another rejection. So this rejection region is what, or is also called the tail of the distribution, right? So the tail. And this, or the probability of this rejection region, is what we called the significance level. Okay? If we are focusing on this tail, we have alpha over 2. It means we have to divide the significance level by 2 to obtain the probability of this tail. Same as this, since they are equal. Okay? Since the two tails are equal. Okay? So if we add the two tails, okay, or the probability of the two tails, we will get the value of alpha, or the significance level. Like for example, if the significance level is 10%, therefore, we have to divide that by 2, okay, para magkaroon tayo ng 5% here and 5% here, okay? So if our significance level is 10%, therefore this middle part of the distribution is, which is what we call the non-rejection region, is 90% probability of having, or the data is approximately 90%. Okay? The data here is approximately 90% since we have 10% on the tails of the distribution. Then we have, okay, suppose we have this table. So another thing to identify the critical value is using the significance level or the confidence level. Okay, so that's why you have to know how to identify the confidence level or the significance level. So suppose the significance level is given. Okay, to find the confidence level, you have to subtract the significance level by depending on the form of the given. So in this case, since nasa decimal form yung ating significance level, we have to subtract it by 1, then multiplied it by 100%. Okay, that's why here 0.01, so 1 minus 0.01 times 100% is 99%. Okay? So if our significance level is 0.01, therefore the confidence level is 99%. Or if the significance level is in percentage form, like for example, this is 5% and this is 10%. All you have to do to find the confidence level is you have to subtract it by 100%. So 100% minus 5% is 95%. Then 100% minus 10% is 90%. Okay? So just do the reverse process. Okay? So subtract this by, or subtract this to 100% for us to obtain the significance level. Okay? So, okay, this is the another illustration. Take note, the total distribution is 100% or 1. Okay? That is the total, the the highest probability, 100%. So, let's talk about the critical value. Okay? Given the significance level or the confidence level. So, if our significance level is 10% or 0.10, therefore our confidence level is 90%. Okay, and each tail contains 0.05 or 5 0.5% probability. 5% probability, okay, each tail. So in that case, our critical value is 1.65. Okay, 1.65. Then, if we have 5% or 0.05 as our significance level, the confidence level is 95%. And each tail contains 2.5% probability. And the critical value is 1.96. Then lastly, we have 0.01 or 1%. Therefore, the confidence level is 99%. And each tail contains 0.005 or 0.5%. Then, the critical value is 2.58. Okay? So, these are the common significance level and confidence level as well as critical values. However, in case that our given significance level or confidence level is not here, you can use your book. Okay, so on your book, you have to go to page 290, table 3. Okay, then um, under under the table or the at the lower part of the table, you will see the confidence level. Then above that confidence level, you will see the percentage. Then above that percentage, you will see the critical value. Okay? So now let's find the margin of error or the maximum error of estimate. So for the margin of error, or for us to find the margin of error, we will use the formula. The maximum error of estimate is equal to Z alpha over 2, which is our critical value, times population standard deviation divided by the square root of n, which is the sample size. So let's solve this problem. A group of statisticians wants to use the mean of a random sample size n is equal to 200 to estimate the average sales of milk cartons of a salesman in a month. Based on the previous computations, the population standard deviation is 7.8. What can they declare with 95% confidence about the maximum error of their estimate? So here, we are looking for the maximum error of estimate that that the group or that a group of statisticians can commit, okay, while they are estimating the average sales of milk cartons. So to solve that, we have this formula, or we will use the formula of the margin of error. So our critical value is 1.96, since here we have 95% confidence. That is our confidence level. So 95% confidence level, we have 1.96 as our critical value. Then the population standard deviation is 7.8. So here we have 7.8 divided by the square root of n, which is 200. Okay? So using your calculator, we will obtain approximately 1.08 milk cartons. You have to round off your answer, okay, into two decimal places. So It means that the statisticians can declare with 95% confidence that their error will be at most 1.08 milk cartons. So they are confident or 95% confident na magkakamali sila ng at most 1.08 milk cartons. So this is at most because of the maximum, okay? Maximum error at most. Or you can change that 95% that their maximum error will be 1.08 milk cartons. Okay? So another example, using the data of the number of hours of free time of selected 40 grade 12 students presented at the start of the section where the sample mean is 2.285, what can be said with 99% confidence about the maximum error of the sample mean with standard deviation of 1.045 as an estimate of the number of hours of free time of grade 12 students between classes. Okay, so we are looking for the number of hours or the maximum error of estimate regarding the number of hours of free time of selected 40 grade 12 students. So, okay, same process. You have to identify the critical value, the population standard deviation, and the sample size to find the maximum error of estimate or the margin of error. So, as you can see, we have 99% confidence. So, that is our confidence interval. Using your book or the table I presented earlier, you will see that the critical value is 2.58. Okay, so 2.58 times the population standard deviation, 1.045, divided by the square root of n, which is 40 selected grade 12 students. So using your calculator, we will obtain maximum error of estimate is approximately 0.43 hours. Okay? So we will be having, this shows that with 99% confidence level, the error of the sample mean will be at most 0.43 hours. Okay, so if they estimated that the population mean is approximately 2.285, therefore their maximum error or the maximum error that they can possibly commit is 0 point or at most 0.43 hours. Okay, so pwede po sila magkamali ng 0.43 hours sa estimated value of the population mean. So another example, a team of experts wanted to use the mean of random sample size n is equal to 200 factory workers to estimate their average learning time. Based on experience, the experts assume that the population standard deviation is 8.3 for such data. What can they assert with 95% probability about the maximum error of their estimate? So, okay, same process as well. And we've noticed that our confidence level is 95%, okay? Therefore, our critical value is 1.96. Then, the population standard deviation is 8.3, and the number of factory workers or the number of sample size or the sample size, we have 200, okay? So using your calculator, we will compute 1.96 times 8.3 divided by the square root of 200. That is approximately 1.15. So this means that the experts can assert with 95% confidence level or with 95% confidence that their error will be at most 1.15 units of time. Okay? So dito naman po, pwede silang magkamali ng approximately 1.15 units of time sa average learning time of the factory workers. So let's move on to the confidence interval. So this is what we call the interval estimate. So i-identify na natin kung kung ano po yung ating range of values to estimate the population mean. Okay? And to make it possible, we will use this formula. We have the population mean is greater than the sample mean minus the margin of error, but less than the sample mean plus the margin of error. Okay? In that case, we will be needing the sample mean and the margin of error. Okay? So, let's have this example. The principal of a large senior high or senior high school wants to estimate the average age of grade 11 students enrolled during summer. It is known from the previous studies that the standard deviation is 2 years. A sample of 50 students shows the mean to be 17.4 years. Find the 95% confidence interval of the population mean. So, to make it possible, kailangan po nating hanapin yung nasa formula. Okay, so let's identify the given. So, our sample mean, here we have 17.4 years. Then, critical value is 1.96 because we have 95% confidence interval. Then we have population standard deviation is 2 years and the sample size is 50 grade 11 students. So next step, you have to find the margin of error. So using the formula, critical value times population standard deviation divided by the square root of the sample size. So our critical value is 1.96. Population standard deviation is 2, then square root of n is square root of 50. So let's simplify that using the calculator. We will obtain approximately 0.55. Okay? So in that case, we will use this 0.55 to obtain the interval, okay, as well as the sample mean. So for our step number 3, we have to find the interval. As you can see on our step number 3, we have the population mean is greater than the sample mean is 1 or the sample mean is 17.4 minus the margin of error which is 0.55 but less than the sample mean is 17.4 plus the margin of error is 0.55. Okay, when we simplify that, we have the population mean is greater than 16.85 but less than 17.95. So this will be our interval. For our interpretation, we will be having the average age of grade 11 students enrolled during summer is between 16.85 to 17.95 years old. Okay, so this is our final answer. But the interval estimate is this. Okay, on our step number 3. Now, let's talk about the minimum sample size. So here, for us or for the researchers to obtain an accurate result, they have to know the minimum sample size na kailangan nila para sa kanilang studies. Okay? So, ganun din po sa atin, kapag mayroon tayong studies, hindi po tayo basta kukuha na lang ng sample size sa ating population. Okay? Kailangan po nating i-identify yung minimum sample size na pwedeng kuhanin sa isang population so that magkaroon tayo ng accurate na answer. Okay? So, for us to find the minimum sample size, we will manipulate or we will use the formula for the margin of error to derive the formula for the minimum sample size. Okay? So in that case, we have this formula. Minimum sample size or the sample size n is equal to the quantity of or the square of z alpha over 2 or the critical value times the population standard deviation divided by the margin of error. Okay? Or, to make it simple, we will use n is equal to the quantity of the critical value times the population standard deviation divided by the margin of error squared. Okay? So, let's proceed to the example. So, a researcher of a cardboard manufacturing company would like to know the estimated thickness of the cardboard, the medicine, or of the cardboard the medicine produces. How many cardboards should he measure if he wants to be 99% confident that the estimate is accurate to 1 millimeter? Study shows that the standard deviation is 3 millimeters. Okay, so for us to find the minimum sample size, ang kailangan po natin ng 3 given. Okay? So, those are the critical value, the margin of error, and the standard deviation of the population. So, here, we have 99% confidence level. Then, our margin of error is 1 millimeter because it says that magiging accurate po yung ating estimate kapag mayroon tayong maximum na error na 1 millimeter. Okay? So, magiging accurate tayo kapag umabot doon sa 1 millimeter na yon. Okay? So, ang atin pong standard deviation of the population is 3 millimeters. So, to show you the steps on how to solve the minimum sample size, we have 3 steps. First, identify the given. Okay? And these are the given on our problem. Then, step number 2, we will use the formula to solve for the sample size. So, n is equal to, the critical value is 2.58. Okay, 99% confidence level. Therefore, critical value is 2.58. Times the population standard deviation is 3 divided by the margin of error is 1. Then, squared. Okay, using the calculator, we will obtain n is equal to 59.9076. Okay? And in this case, since we are talking about sample size, 'di ba? Kailangan po ang ating sample ay whole number. So dapat i-round up po natin ang ating final answer. Again, round up the final answer. Pataas po ang pag-round, ang pagkakaroon po ng final answer ay dapat po ay whole number, then round up. Okay, so 59.9076, round up po, that is 60. Therefore, for step number 3, the researcher needs a sample size of 60 cardboards to be 99% confident that the estimate is accurate to 1 millimeters. Okay, so as you can see, 60 cardboards po ang kailangan po or minimum sample size na pwedeng kunin sa ating cardboards, para magkaroon tayo ng accurate na result or accurate na data na gagamitin to obtain a good result. Okay? So, ayun po. That's all for today. Hopefully po ay we are able to understand the estimation of the mean. Thank you so much, everyone, and God bless you all.